Let's practice writing some reciprocals together. So in each of these practice problems, we're going to go ahead and write the reciprocal of each of the given numbers. Then we're going to go ahead and show that the product of the original value or the given fractions or values and the reciprocal is always going to be equal to 1. For number 1, we have the fraction 3/8. Now, 3/8 is a fraction that we can write a reciprocal of right away, which is kind of nice. So you take this fraction 3/8 and all you have to do is go ahead and flip it upside down essentially, right? So if you flip the 8 and move it to the top, and move the 3 and move it to the bottom, then we have 8/3. Now keep in mind for the reciprocal, it is 8/3, but you can also write it as a mixed number, and 3 fits into 8 2 times with 2 left over. So you can also say the reciprocal is going to be 2 and 2/3, okay? So the reciprocal for 3/8 we can say is either going to be 8/3, like this one over here, this improper fraction, or you can say it is 2 and 2/3, which is just the same thing but in mixed number form. Okay. Now in the directions it does say to go ahead and show that the product of the original value and the reciprocal is equal to 1. So the original value was 3/8, right? That was the one we started with. The reciprocal we found out was 8/3, so we're going to show the product, which is the answer to a multiplication problem, is equal to 1. So if we go ahead and see that this 3 times 8 on top, that's going to be 24, and then 8 times 3 on bottom is also going to be 24. 24 over 24 is equal to 1, so we know that this does work. All right, here's number 2. For number 2, we have the fraction here of 9/2. Now 9/2 is a type of fraction that we can also just get started with right away. So we have 9/2. We're going to start with this. So the original is the same thing as 9/2. And if we want to write the reciprocal, we just flip it upside down and we're going to make it 2/9. All right, so that's the reciprocal here. And if we would like to try to see if we can go further, you can't make it a mixed number or anything just because it's already a proper fraction. So this is the reciprocal and we can't go any further or do anything else. All right, now if we're going to go ahead and just see it to show the product is equal to 1, the original is 9/2. And then we got the reciprocal of 2/9, right? So this should equal 1 if you multiply these. 9 times 2 is 18 on top. 2 times 9 is 18 on bottom. 18/18 is equal to 1. So this does check out. All right, for number 3, we have the number 10. Now we want to rewrite this so that it is something we can actually reciprocate. So we have, go ahead and write 10. That's equal to 10/1. So that's what we're going to do first. So we can actually see what we're doing with the reciprocal. So we have 10/1. If we flip that, that's going to be 1/10. All right, so that's how we're going to write the reciprocal of 10. Just be careful to start off by writing it over 1 first, okay? It's a proper fraction, so we can't do anything else. Now the original here was going to be what, 10/1? And if we want to show that the product of the original with the reciprocal is equal to 1, well, on top 10 times 1 is 10, on bottom 1 times 10 is 10, and so 10/10 is equal to 1 whole. So this does make sense. All right, let's move on to number 4. So for number 4, we have 5/12. Now that's a proper fraction, so we can just leave it alone from the start. And so if we want to go ahead and find the reciprocal, this one's actually kind of nice. We don't have to do anything. We just flip it upside down, so we're going to get 12/5. All right, so that's one way you could write the reciprocal here. That's perfectly fine. But if you also want to write the mixed number version, you may see it like this as well. 5 fits into 12 2 times with 2 left over, so we're going to have 2 and 2/5. So this would be also considered the reciprocal, and you can have it written as a improper fraction or a mixed number. Now if we want to show that this does the product of the original 5/12 and the reciprocal, well, you just use the improper fraction version just because it's easier to multiply. 5 times 12, that will be 60. 12 times 5 will be 60. 60/60 is just equal to 1, so this does make sense. Let's check out number 5. For number 5, we have the number 5, okay? So again, to get started with whole numbers, all you have to do is put it over 1 first. So that's the original. The original value is just 5/1. If you want to find the reciprocal of this, you just flip it. It's going to be 1/5. Now this is a proper fraction, so we can't do anything else. We're just going to end with that. Now if we want to show that the original, which is 5/1, the product of that with its reciprocal of 1/5 is equal to 1. Well, 5 times 1 on top is 5, and on bottom 1 times 5 is 5, and 5/5 is equal to 1. So you can see that this does make sense. All right, for number 6, we want to take a look at this. This is a mixed number, and we want to say, we can't really flip it right away, so let's go ahead and see what we can do here. So if we do 5 times 2, that's going to be 10. 10 plus the 4 on top is going to be 14. So this mixed number is the same thing as 14 over 5. So that's the original. I'm just going to go ahead and write it here, 14 over 5. And if we want to find the reciprocal of this, now that we have an improper fraction, we can do so. If we flip it upside down, it's going to be 5 over 14. All right, so if you have a mixed number, just be careful. Make sure you write it as an improper fraction before you reciprocate it or flip it upside down. All right, showing that the product of the original was 14 over 5, and its reciprocal, which we just found out, is 5 over 14. 14 times 5 on top is going to be 70, and then 5 times 14 on bottom is also 70, and 70 over 70 is 1, so this hopefully makes sense. For 7 and 8, number 7, it looks like we have another mixed number, so we have to do 3 times 2, which is going to be 6, plus the 1 on top is going to be 7, so 3.5 is the same thing as 7 over 2. Now this is what we can use to find the reciprocal, so take the 7 over 2, flip it upside down, that's going to be 2 over 7, and I think that's it. That would be the reciprocal. Because it's a proper fraction, we can't go any further. And to show that the product of the original is 7 over 2, and the reciprocal, which is 2 over 7, this should equal 1, right? So 7 times 2 is 14, and then 2 times 7 is 14. 14 over 14 is equal to 1, so this checks out. For number 8, we have another mixed number, so let's go ahead and turn it into an improper fraction first. So 6 times 3, that's 18 thirds, plus 2 more thirds, so this is the same thing as 20 over 3, or 20 thirds. So this is the original, 20 over 3, and if you want to find the reciprocal, we just flip it upside down. It's going to be 3 over 20, and this is kind of nice because we don't have to do anything else. This would be the reciprocal. Now to show that the product, the original number is 20 thirds, and the reciprocal, which is 3 over 20, is equal to 1. Well, on top, 3 times 20, or 20 times 3 is 60, and on the bottom, 3 times 20 is also 60. 60 over 60 is equal to 1, so this does equal 1 when you multiply the original fraction with its reciprocal. For number 9, we have a whole number of 4. Okay, so how do you rewrite whole numbers as fractions? Well, 4 over 1 is going to be the same thing. So here we have 4 over 1, and if you want to find the reciprocal, you can go ahead and flip it upside down to make it 1 over 4. So nice and quick, we have the reciprocal of 4 is just 1/4, and if you take the original of 4 over 1 and multiply that by 1 over 4, 4 times 1 on top is 4, and 1 times 4 on bottom is 4. 4 over 4 is equal to 1, so this makes sense. For number 10, we have the fraction 3/14. We don't need to change that at all. We can just leave it alone as 3/14. So let's go ahead and write 3 over 14. If we find the reciprocal of this, then that's actually going to be 14 over 3. Right, that's one way of writing our answer, or we can go ahead and maybe write it as a mixed number. So how many times does 3 fit into 14? I think 3 times 4 is 12, so 12 is 2 away from 14, so 4 and 2/3. So in terms of the reciprocal, you can either write it as this version. This is more useful for multiplying and dividing, and then this version, which may be useful for a final answer sometimes, especially in word problems, but both of these would be considered the reciprocal. Now to show the original, which is 3/14, multiplied by the reciprocal, again we like using the improper version, that this is equal to 1. That has to be true. So 3 times 14 is 42 on top, and then 14 times 3 is 42 on bottom. 42 over 42 is just 1 whole, so that checks out. Moving on to 11, we have 7 and 2/3. That's a mixed number, right? So we can't use this right away. If you have 7 of these thirds, that's going to be 21 thirds, right? Total 21 thirds plus 2 more thirds. That should be 23 thirds. All right, so this would be the equivalent or the same thing, so 23 thirds. If we want to find the reciprocal of this, we flip it upside down. That'll be 3 over 23. And I think that's it, right? Because that's a proper fraction, so we can't do anything else to it. Now to show that the original of 23 over 3 multiplied by what we found the reciprocal to be 3 over 23, 23 times 3 will be 69, and 3 times 23 will also be 69, so 69 over 69 is equal to 1 whole, and so this hopefully makes sense. For number 12, we have the number 6, right? Now 6 is a whole number, so hopefully you know that's going to be 6 over 1. That's the original. And if we want to find the reciprocal, you flip it upside down and make it 1 over 6. This is a proper fraction, so we cannot do anything else. And to confirm that this is true, that these are reciprocals, you take the original, you multiply by its reciprocal we got. 1 times 6 on top is 6. 6 times 1 on bottom is 6. 6 over 6 is equal to 1, so we have proved that they are indeed reciprocals of each other. For number 13, looks like we have a decimal here, so be careful what to do with this. Think about 0.25 or 25 hundredths. This is the same thing as 1/4 or 1/4. It's like saying 25 cents is 1/4. So this is the original. And if you want to find the reciprocal of this, that's just going to be 4 over 1, right? You should go ahead and simplify this and say this is going to be 4 though. Okay, so 4 would be the most simplified way of saying that this is the reciprocal, but yes, of course, this is also technically the reciprocal, right? Because if you want to show that these are reciprocals, you would take the original of 1/4, you would use the improper version of 4 over 1, because it's easier to use to multiply. 1 times 4 is 4, 4 times 1 is 4, 4 over 4 is equal to 1, so this does hopefully check out. Okay, you would need 4/4 to make a whole dollar. For number 14, we have 3.5. So this one's pretty interesting. So 3.5 or 3 5/10 is the same thing as 3 1/2, right? So 0.5 is a half. Now, if you want to convert this, we still need to do one more step and make this an improper version, improper fraction. So 3 times 2, that's going to be 6 halves, plus 1 more half, that would be 7 halves. Okay, so we're taking this and we're rewriting it so it's going to be 7 over 2. So the original of 3.5 is the same thing as 7 over 2. Now if you want to find the reciprocal of this, you flip it upside down, you're going to get 2 over 7. This is a proper fraction, so we must be done. If we want to go ahead and just show that the original times the reciprocal is equal to 1, well the original, the version that is most useful to us is 7 over 2. Again, that's the same thing as 3.5. And if you multiply that by the reciprocal we found of 2 over 7, 7 times 2 should be 14 on top. And then 2 times 7 is 14 on bottom, so 14 over 14 is equal to 1. All right, cool. Last couple problems here for number 15. How do you think about 15? This is 0.6. If you read that properly, that's going to be 6/10, right? So 6 over 10. Now, if you go ahead and think about this, now 6/10 has a GCF of 2. The 6 and 10 have a GCF of 2, so if you go ahead and divide them by their GCF of 2, you're going to get 3/5. All right, so that's the version we're going to want to use. So we're going to take this 3/5, and let's go ahead and find the reciprocal of it, and that's going to be 5/3 if you flip it upside down. All right, so you can leave your answer as 5 over 3, or you can turn it into a mixed number. So 3 fits into 5 one time with 2 left over. So it'll be 1 2/3. So for the reciprocal of 0.6, you could say it's 5/3, or you could say it's 1 2/3. Okay, now let's go ahead and see if this makes sense. If you take the original, remember the original was 0.6, but we're going to use the most simplified version of its fraction form of 3/5. And what did we find the reciprocal was? We found it was 5/3. Okay, now on top, if you multiply 3 times 5 is 15. On bottom, 5 times 3 is 15. 15 over 15 is equal to 1, so this hopefully makes sense that these are reciprocals of each other. Last problem we have for number 16 is 2.75 or 2 75 hundredths. So if it's 75 hundredths, 3/4, this is 2 3/4. That would be the mixed number version, but we can't use that one either, right? So if you multiply 2 times 4, that's 8. 8 plus the 3 on top, that's going to be 11. So this is equivalent to 11/4, or that's the same thing. Now if you take this 11/4 and we try to find the reciprocal of it, then if you flip 11 over 4 upside down, that should be 4 over 11. And that's all we have to do in terms of flipping it upside down to get the reciprocal, because that's a proper fraction. Now to show the original, which is 11/4, multiplied by the reciprocal of 4/11 is equal to 1. On top, 11 times 4 is 44. On bottom, 4 times 11 is 44. 44 over 44 is equal to 1, so this does hopefully make sense. So there you have 16 different practice problems on turning some given values, some fractions and decimals, into their reciprocals. And remember, if you ever take a value or a number and multiply it by its reciprocal, you should always get 1. All right, that always has to happen. So if you found this video helpful, please consider giving it a thumbs up. And as always, keep with the great work, and I'll see you in the next one.